Okay, so we have our periodic table nice and annotated. So let's say we were asked to give the electron configuration of bromine. Well, first find bromine, it's number 35 here. So we're gonna have to go 1s2, that would get us 2 electrons, right? 1, 2 to get us to helium. 2s2, that gets us lithium and beryllium. 2p6, that gets us to neon. 3s2, that gets us to magnesium. 3p6 gets us to argon. This is one long line here. 4s2, that gets us to calcium. 3d10, that gets us to zinc. And then we have to be careful here. We're at 4p, 4p1, 4p2, 4p3, 4p4, 4p5. That gets us to bromine. So that would be a correct answer. That's the full notation for the electron configuration of bromine. We also learned how to do an abbreviated notation, which takes less time. You go to the previous noble gas. So here's bromine, the previous noble gas. It's not krypton because that's ahead of bromine. It's argon. And so then you can just abbreviate this. You go bracket argon, and that gets you to argon. So now you can just go bracket argon 4s2, 3d10, 4p5. Essentially this end portion of the bromine. So I mean, you can kind of do this all day long. There are exceptions to the this sort of rules of how it's called the Aufbau principle of this building up of the different orbitals, like I showed you on the previous slide. We're not worried about those rules in this course, okay? So you know, I can't explain to you with the knowledge that you know why those exceptions exist, so why should I teach it to you? That's how I feel, okay? So calcium, let's just go through it. 1s2, 2s2, that gets you to beryllium. 2p6, that gets you to neon. 3s2 gets you to magnesium. To get to argon, that's 3p6, and then calcium is 4s2. So we're done there. We could also go to the nearest noble gas that's before it, that'd be argon. So that'd just be bracket argon and then 4s2. Cesium. All right, cesium's right here. So we have some work to do. 1s2, 2s2, 2p6, that gets us to neon. 3s2 magnesium, 3p6 argon, 4s2 calcium, 3d10 zinc, 4p6 krypton, and now we are at 5s2, right, we're down here, strontium, 4d10 cadmium, 5p6 xenon, and finally 6s1 cesium. Much simpler way is just to go to the nearest noble gas behind it, that's xenon. That gets you all the way up to here, 5p6, right, xenon. And now that's just gonna be bracket xenon, 6s1, done. That's also an acceptable answer. So, you know, multiple choice on the test, either one of these, you know, look for, either one of those would be correct. All right, guys, let's just do ognoson, right? Ognoson is element 118. If you can do ognoson, you should be able to do any element pretty easily. So one way would just be bracket ognoson, right? But that's kind of cheating. It's pretty easy. But let's actually go through the full nomenclature here, okay? It's gonna be 1s2, 2s2, 2p6, 3s2, 3p6, that got me to neon, 4s2, 3p6 got me to argon, okay? 4s2 got me to calcium, 3d10 zinc, 4p6 got me to krypton, 5s2 got me to strontium, 4d10 gets me to cadmium, number 48. Now I'm at 5p6, that's xenon. 6s2, that got me to barium. Now I have to go down to the F block, 4F, and there's 14 of them, okay? That gets me to lutetium, then back 5d10, that gets me to mercury. 6p6, that got me to radon. Now I'm back to francium, that is 7s2. Now I'm back to actinium here, that's the F block, so 5f14. And finally, So that got me, so no, not finally, rutherfordium to Copernicum. That's going to get me what? 6d10. And finally, to get to Ognoson, going here to Ognoson at the end, that's going to be 7p6. So again, if you can do that, you add up all these, 2 plus 2 plus 6, etc. That's going to be equal to 118, right? There's 118 protons in Ognoson. There's 118 electrons in Ognoson.